everyone, it's Casey Vineyard here at Wonders of Wildlife National Museum and Aquarium. We are so excited to have you here as we talk about our mission for the month of May through Mission Conservation, Bird Basics. Throughout the month of May, you will get to meet multiple partners to learn exciting facts about different species of birds. Get ready to dive into fun facts about these feathery friends. So in order to play this really fun mission, all you have to do is log on to our mission conservation page at www.wondersofwildlife.org/mission-conservation, and that will bring you to our mission conservation webpage. So on this website, I will bring your attention down to get the app. Once you click download, that'll take you to download the Agents of Discovery app, which you will need to play any mission conservation mission. Once you have that app downloaded, create a user account and log in. Hit the search bar and type in Mission Conservation. This is where we house all of our at-home missions for you to play at home. Once you have the mission popped up and loaded, hit play and get ready for your fun adventure. If you're looking for more bird-related activities, we're going to direct you down to another part of the website where it says Schedule of Missions and Activities. This tab will show you all of the missions that we currently have live, including our current mission, Bird Basics. Under this tab, you will also find our activity guide that we have specifically made for you at home. So there will be a craft, an awesome outdoor activity, and something that you can do to promote conservation for birds. So speaking of birds, I'm currently standing here in our Year of the Bird exhibit. This exhibit houses multiple lives with different species of birds in their natural habitat. We also have photographs from Nature's Best Photography, Audubon's art collection, information on the Migratory Bird Treaty Act of 1918, and so much more. And that brings us to our partner for the day. You may recognize his name because he has been here before and he is an avid biologist. Dr. Gord Court, how are you doing today?
Very good, Casey. Good to be here.
Yeah, we're super excited to have you. What do you have for us today?
Sure, we're going to talk about one of the greatest conservation success stories involving a bird, the return of the peregrine falcon. I'm just going to share a screen. I think you can see that, can you?
Great.
Okay, I'll start off. Just interrupt me if you have any questions, and I'll just try and reel through these slides fairly quickly, and maybe we'll get a visit with our live bird too, or Vinny, in a few minutes. I'll just give you the brief history of quite a long program, but it was a very successful one. I'm pleased to tell you about it. The peregrine falcon is really well known to most people in the world. It's if you're looking at this book of world records, you'll see that it's considered the fastest thing that ever lived before people started to fly around with jet aircraft anyways. Very, very dynamic species. It's well known to us because it was a preferred bird in the sport of falconry. So before we had invented the shotgun, we used peregrine falcons and other raptors to capture birds like ducks and upland game birds like pheasants and that sort of thing. So we were well known to use falcons for that period of time, virtually all across the world. The other reason that we know peregrines is that they occur just about everywhere on Earth where people do. They have a huge distribution, one of the largest distributions of any wild bird, rivaled only by the raven, the barn owl, and osprey, if you look at total coverage, total area covered by the bird. Not surprisingly, the bird has diverged on island populations and in many of the populations around the world to some differences, and there are 19 different subspecies of the bird recognized, from very, very large species, dark forms like the one right in the middle top there. That is a bird that would nest on the west coast of the United States, or west coast of Canada, on the Haida Gwaii or the Queen Charlotte Islands. This is the one here. The one, that tiny little one on the top, the smaller one, the white, very highly migratory one that's right in the middle top, the Falco peregrinus tundreus. This is the one that nests north of the tree line in North America. The big one I was just mentioning, Pelii, is a big one that nests on a coastal environments on the northwest coast of North America. And the other one that we nearly lost, the one that had the most trouble with was Falco peregrinus anatum. And anatum, freely translated, means the one that eats duck. So it's in recognition of the fact that it was once called duck hawk as a common name in North America. And it's characterized as by a beautiful dark head and sort of a peachy ventral surface. It was quite a pretty falcon. What I'm going to do here is just give you an idea of what peregrines, the problems that peregrines had with certain pesticides or insecticides that we had developed, give you an idea of the scale of the decline worldwide, and then give you an idea of how we manage this and what the future may hold for the species. So we're going to do that in about 20, 25 minutes, I hope. So I should mention that peregrines were extremely successful, are extremely successful, but they enjoyed this success up to the time where we manufactured and disseminated a single group of man-made compounds, the organochlorines, and especially organochlorine pesticides. Now, it's important to remember that these compounds were never present in nature before people started to mix carbon, hydrogen, and chlorine in the lab with the advent of the organic chemistry. And some of the ones that they came up with quite early were infamous ones like DDT. And this is an insecticide that has very low toxicity to vertebrates, but really works very well on insects and was used in a huge way just after World War II. So it really was not appreciated as an insecticide until just during and after World War II. Some of the other cyclodiene compounds here that you may recognize if you've ever had or treated someone for head lice, lindane, or here, benzene hexachloride. This is a circular molecule here again. And again, these ones were used to kill insects that were eating crops, often used as seed dressings to put on seeds before you put them in the ground so that you could kill off insects that were going to take out your seed bed. And also there's a related group of compounds here that are not insecticides, but are also organochlorines. These are the polychlorinated biphenyls. These are things that accumulate, especially in marine systems. These are very closely related molecules that often work in the same way, and they're something we have to keep an eye on as well. And these groups have one thing in common, and that is that they're fat soluble. In other words, they're stored in animal fat. And when that happens, when one animal eats another, it instantly assumes all of the organochlorine residue in that animal that it just ate. So you have a situation where it very quickly magnifies in food chains. And you've probably seen this in your biology courses in school, where you have very, very low levels of insecticide application in freshwater or seawater. And that's very rapidly accumulates to higher levels and higher levels each step of the food chain. And you end up with some very, very high levels relative to the application levels in things like birds of prey, in things like polar bears, and even people. So this is a common thing. And when we see DDT residues in prey, it usually goes straight to the peregrines and accumulates very quickly, especially if the birds are eating insectivorous prey, like swallows or nighthawks or things like that take a lot of insects. And the DDT in peregrines builds up, and it causes one of two things. It can cause the embryos to die in the egg, which is rare, but it also causes shell thinning and egg breakage eventually. So it reduces the thickness of the bird's shell, and the eggs break before they're able to hatch, and you have a reduced production of young and a population decline. And this was recognized during the 1960s, and it continues today, but at a much lower level than it did in the past. And it wasn't just peregrine falcons, it was anything, mainly birds that ate either other birds or fish. And you had many fish-eating birds like bald eagle, brown pelican, declined, osprey declined really, really precipitously in the 1960s, along with peregrine falcons. So it wasn't just the falcons, it was a whole group of other birds, mainly those that ate fish and birds. We now know that pesticide pollution and eggshell thinning in birds is a well-known fact. This has been studied in field and lab for over 40 or 50 years, and the results are unequivocal. We now know how it works. The biochemical pathway is understood. What happens is when the DDT is taken into a bird's body, it rapidly changes to a primary metabolite, which is DDE, and DDE masks an enzyme in the body called carbonic anhydrase. And this enzyme is released in the bird's body to liberate calcium in the bird's body, to liberate it from the bones of the birds, to allow it to become systemic in the blood and to go to the shell gland and to be deposited as a shell on the outside of the embryo, outside of the actual egg itself. And what happens is if you have high levels of DDE in the body, it fools the body into thinking it has high levels of carbonic anhydrase in the body, and you have lower deposition of calcium on the shells. And that's the actual biochemical pathway that it works. And it, that's kind of sciencey and geeky, but it's actually the fascinating that it was discovered entirely by accident. And it's a really, really neat story. In Britain, the British racing pigeon lobby complained to the government about peregrine falcon numbers in 1960. They were causing unnecessary mortality in their pigeons that they were racing. And this is big business in Britain and Europe, where they race these pigeons from one end of the country to the other. And the peregrines or the pigeons that come back to the loft first are awarded a prize. And there's a lot of betting that goes on with it, just like horse racing, dog racing. These are big businesses. And so they had quite a lobby, and they were concerned that as early as 1960s that peregrines were interfering with their hobby. And they lobbied the government to look in to see whether or not peregrines were really overrunning the country and wiping out the pigeon population. Well, they hired a young guy right out of school named Derek Radcliffe, a very clever fellow who investigated and surveyed the peregrine nests in southern England and in the early 1960s. And he found that the peregrines weren't overrunning the place. They were actually gone from many of these nest sites that had been known to have been occupied for centuries. And they were known to have been occupied because peregrines come back to the very cliff every year, very same cliff every year to breed. And they were gone. And he didn't know what was going on there. And he was very surprised to see it. And he watched a lot of these peregrines in the early 60s to see what was going on. One thing he did notice was a lot of them did not have eggs. They were on territories, but they failed to produce eggs, or if they had eggs, they didn't have them for very long. And he was watching one day in the Lake District of Britain, he was watching a bird that was laying eggs, and he saw the bird turn around and just eat contents of what it had laid. And he surmised that there must be something wrong with the egg. So very fortunately for Radcliffe, peregrine eggs are extremely beautiful, and they were prized by egg collectors all through the late 1800s and early 1900s in a hobby called oology. And back then they didn't trade in baseball cards or football cards or hockey cards. They traded eggs, and it was a huge business and a very big hobby for a lot of people to collect eggs. And peregrines were a real popular one because they were so pretty and they were hard to get to, being on cliffs and that sort of thing. As time went on, these eggs usually ended up getting into museum collections. People would leave them to the museum, and they had data and they had information when it was taken, where it was taken. And Radcliffe said, "Hey, I think there's something wrong with peregrine eggs." He went to the British Museum and asked, "Can I borrow these peregrine eggs?" He says, "Yeah, you can borrow them, but you can't do anything to them. You can't subject them to chemical analysis. You can't do anything. We want them just back just the way we gave them to you." So what he said is, "I'm going to try and figure out a way to measure egg quality." So he took the length of the egg and the width of the egg, and he divided that into, or divided the weight of the egg by that product, and he was able to get an index of shell quality. So that gave him an idea of whether or not there'd been a change in the eggs themselves. And he plotted this. You can see how many eggs were involved here in the British Museum from 1870 to 1975. He just plotted that Radcliffe index of the eggshell quality, and you can see right there already at 1947, just after World War II, was a perceptible decline in the quality of eggshells at that point. And that was the first circumstantial evidence linking the change in eggshell quality in peregrine falcons and the introduction of DDT, which was used very, very heavily after World War II, mainly to control lice that were on rats and cats were transmitting typhus in Europe. And by killing off the insect, you killed off the vector of the disease. And some people speculate that DDT probably saved more lives in those first few years after World War II than were actually taken in World War II. So it was a very, very effective insecticide. And it was really when people started to really fall in love with DDT as a means to control insects, and it was considered really a miracle. And people started to use it on everything. And over the years, though, we discovered that Radcliffe was right, that once we have a certain amount of DDE in the body, you will see a decline. This is just what they call a regression, that you see a decline in eggshell quality with increases in DDT in the body. And that relationship there was really what spelled the end of DDT and some of the other organochlorines. And it took about 40, 45, 50 years to determine that and prove it unequivocally, so that we had a case against DDT. Just wanted to show you how widespread the eggshell thinning phenomenon was. You see these are eggshell percentage thinning, percent thinning below normal, and you can see there virtually no population of peregrine falcons on the planet were spared this problem. And you can see birds even down in places like Tasmania, way up in Siberia and Alaska. These are migratory populations in the north that are coming down to the south and Central and South America for the Alaskan populations, and they're accumulating big residue amounts there and having breeding problems on their breeding grounds. They're all populations all around the world had this problem. This is just another nerdy bit that I really like to show. It's these are studies. The peregrine falcon is the best studied bird in the world, other than domestic chicken. And so this DDT issue and the whole idea of pollution causing reproductive failure in birds was very, very, people were very, very keen to study it. You can see there's studies from all across the world here, and you can see that any population that was studied that had shell thinning that was below 17% of normal. In this case, it just had anything having 17% shell thinning or less was going to be fine. They were stable. Anything more than that was either declining or had been extirpated. So it just shows you the level of study that went into finding this out and finding it out all over the world. And this sort of concern and this sort of science that was coming out during the 1960s is really what launched the modern environmental movement. And people like Rachel Carson at the U.S. Forest Service, she was the one to first blow the whistle on what we were doing with these organochlorine pesticides and how we were using them indiscriminately and causing bird declines and in fact regional extinctions in some species of birds, and really gained a lot of support for looking into what we were doing with these compounds and how they should be better managed in the future. And certainly the peregrine was one of the species that was at the forefront of this sort of movement. So the case against DDT, again, it was a little bit like the global warming stuff that we see. There's concerns in the 60s, acrimonious debate, a lot of people saying, hey, this is junk science, we don't like it. There was just too much money involved to curtail the use of some of these compounds, billions of dollars at stake for restricting them. But some of the countries did. Canada banned the use of it domestically in 1969, and USA banned the domestic use of DDT in 1972. But what did that mean for peregrines? Well, again, just like Radcliffe, scientists in North America were able to go back to the very cliffs where peregrines nested every year to see if they were there or not. This is an example of what we use. A helicopter is perfect for this sort of thing. These are large cliffs with golden eagle nest on there, and you can see right in the corner of that nest is a peregrine falcon standing over a couple of eggs there, and that's sort of what you can see. They really ignore the helicopter for the most part, and you can count them, and they'd certainly determine whether or not they're there year after year. And in this case, we were able to survey peregrine falcons internationally with the U.S. and Canada doing full inventories of all historic peregrine eyries in 1970, 1975, 80, and 85. And in fact, most people even counted them in 1995. And what we found was certainly they were on their way out. They were gone from most of, by 1975, they were extinct east of the Mississippi River in the United States. There were sort of diminished populations in the West. In Canada, the bird was gone completely east of the Rocky Mountains and south of the boreal forest. So it was all through the sort of the settled parts of Canada. The bird was gone for the most part. But what did we do? Well, we had to do something pretty heroic, and people said, we're going to just have to grab the last of the peregrines that we can find, take the young ones. Falconers gave them birds, and they learned to domesticate the peregrine falcon at a number of facilities. One of the ones that led the charge was Cornell University in New York. The Canadian Wildlife Service had a facility in Wainwright, Alberta. Fort Collins, Colorado had another facility. And the Peregrine Fund, as it turned out to be, was a very big organization and continues to be a big conservation organization in the States, where they started out by domesticating the peregrine, learning how to breed it in captivity, and certainly developing the techniques for breeding raptors in general in captivity, which had not really been bred in captivity. Here's the old Wainwright facility. These are old photographs of them. They put peregrines in these pens. They made a lot of mistakes, but they got a few things right. And they certainly, in time, started to produce young peregrines and learned, how to produce them in bulk. Now, we never really got super at getting thousands of them out at any one year, but certainly hundreds per year with all facilities combined. And it wasn't long before we had a chance to experiment, perhaps, with reintroducing this species to its former range. And what we did was, even by 1975, we put young peregrines like this back in nests of pairs that had had their eggs broken, or else we used a technique called hacking, where we would take birds to their old nest sites where they had previously bred. We built a small box on the edges of these cliffs. This was done all across Western North America and certainly in the East as well, with these hack boxes. And this is a technique where the falconers used to get young birds to return to these boxes every day. Once they would learn that that box meant food, they lived in the box, and eventually they were released from that box. And even without any guidance from their parents, were able to recolonize these areas and certainly learn to hunt and migrate even without any guidance from their parents. And this was a fairly successful way of reintroducing peregrines across North America. And what happened when they did return to breed, we didn't get them back places necessarily where we thought we'd get them back, which was their historical nest sites or historically used nest sites. They came back to the cities, which offered great cliffs in the way of skyscrapers and large buildings. And once these few birds came back, it was announced that, oh, we've done the job. Falcon's returning as a new life for the peregrine. It's a success story. Actually, well, it's always a little bit unfortunate that we had managed peregrine falcons nationally, but the peregrine issue was international. And when we restricted DDT use in North America, certainly in the United States and Canada, we had actually just took the means to manufacture this compound and the compound as it was in storage and just sent it south, where it was used mainly to protect cotton and tobacco plants in Central and South America. So our peregrine falcons are an international species. These are band returns that show you where the peregrines go in the winter. And you can see that the birds banded in Yukon, Alaska. There's no Alaskan birds there. There's some Yukon birds, even way north in Canada, go way, way, way down into Central and South America and spend the winter. And that's where they were picking up pesticide residues that would not allow them to breed when they returned to places like northern United States, southern Canada, and because they were eating birds that also spent the winter in Central and South America. Some of the shore birds were heavily laden with compounds. Not so much some of the local things like ducks that were usually eating grains, but things like grebes, neotropical migrant birds. Here's one we were talking about earlier that I was talking to Casey about, the Franklin gull. This is an animal that is probably 4 or 5 million of them on the central prairies or northern Great Plains in the United States and Canada. And it's the entire population of this animal migrates and winters off the coast of Chile. And if you know anything about Chile, some of the main industry there is vineyards and wine, of course, and those crops are protected by many of these compounds, including DDT, and the legacy contaminants that are probably in coastal Chile are still probably fairly high. And this animal here, though, is used extensively by peregrine falcons during the breeding season and probably contributed to a lot of the failures we saw in the West here in the 1960s and 70s. So that all seems pretty grim, but fortunately, we were able to monitor residues in peregrine eggs through time. This is a typical example of just the number of eggs you might get that were dead, and you could actually run them for pesticides. We knew that there was a fair amount of DDE in the samples that we had. Some as high, you know, we see the very, very, very high levels there. But in general, they were declining, and they declined like this throughout the world. And I'd like to say that it was because of the restrictions that we put on it, on the pesticide. It really was a result of using so much DDT for so long. We had selected for insect resistance, and DDT as an insecticide just didn't work as well as it used to, and it fell out of favor as a pesticide in the 1980s through the 1990s, and has continued to drop ever since. And just to give you an idea, my own research on this sort of worldwide trend, remarkably, it was in Antarctica. This is the continent where we've never used insecticides because they don't have any insect pests. So everything that's in the tissues of wildlife in Antarctica is a result of air currents and water currents bringing these pesticides from the rest of the world. And what we were able to do is chronicle the rise and fall of DDE in those compounds. And it was a tremendous thing to realize back in 1967 when DDT was detected in the tissues of emperor penguins. And people were amazed to think that this thing got that far and could last that long. And what we had at a fairly low level, and it peaked in the 70s, and has dropped ever since and continues to drop in most of the tissues measured here or elsewhere. But we certainly knew that by measuring them in Antarctic wildlife, we weren't seeing anything local, and we could actually use it as a test. The good thing is when the pesticides drop, the productivity of peregrines goes up, and you can see the hatching success in the late 80s and 90s. Just as soon as the pesticides dropped to a certain level, these birds began to hatch their eggs as they had for millions of years, and they did very well. And we saw a very quick recovery of peregrine falcons. These are data from southern Canada. You can see here 1970, that one pair of birds, and it was found in Alberta. By 2010, there were probably close to 300, well, we were counted 300 pairs in 2010. There's probably over 450 pairs back in southern Canada now, all the way across the country to the eastern provinces of Nova Scotia and New Brunswick. We made a tremendous recovery there. And the same thing happened in the United States as well. And we were able to look at these birds and test to see whether or not they had come from birds that we had released. And sure enough, most of the birds that returned came from those breeding programs in Cornell, Fort Collins, and Wainwright. Neat thing is they return to all sorts of habitats, power plants, bridges, hospitals. This is a cement plant. You can see that some of them are quite aggressive. But delightfully, they also return to the very cliffs where their ancestors had been in the 40s, 30s, 50s, and they're right back, sometimes within meters of where their ancestors had been in the 50s and 40s. And this is just in Alberta, to give you an example. Our population is shot off as well. This is a local inventory here. Really nice to see them back. And then we got a chance to delist the peregrine and downlist it, take it off the endangered species list in Canada and in the United States. I was the Canadian component for this review of the science and the evidence that was there to delist the peregrine. And we did do so in 1999 in the United States. It's still waiting for delisting in Canada, but the Committee on the Status of Endangered Wildlife in Canada has recommended that it also be taken right off the species of concern list. It's going to be listed as not at risk. So a tremendous accomplishment overall. Just shows you what you can do when enough people and are doing the right thing for the species. So we have peregrines back, and they are back by popular demand, and it's very great to see them back. And I encourage you, if you're ever in a situation where you can watch peregrines at the nest, to do so, to see that tremendous diving that they can do and these tremendous speeds. I don't know if I mentioned earlier about the top speed. If you do get a chance to look at your YouTube this afternoon, I encourage you to go to a short National Geographic clip called, just search on high velocity falcon, and you'll see people skydiving with their falcons. And There is an airline pilot in Washington State who got his peregrine by skydiving with it, and using a GPS transmitter, he was able to measure the top speed of the bird at 389 kilometers an hour, about 243 miles an hour in a dive. So really neat to see. And with that, I think I'll just go in and try and bring our little guest over here. This is Vinny. He's an educational bird that we have. He's a little bit cranky. He is pretty cute. And there he is. There's Vince. And he's this is an Atom peregrine that I was telling you about. This is the duck hawk. And you can see the sort of peakiness to their plumage, very dark. This guy here was one that we wanted to look at, and we were quite keen on using him. He had a broken wing when he was younger, or very young. He was just learning to fly when he broke his wing. But he had a good temperament, and we were able to use him for school kids and that sort of thing. As you can see here, he's got quite the feet on him, but he's not violent with his feet, and he won't, he won't even bite. So you can see him there. So Casey, I don't know if you want to take questions or send them through, but I'm happy to answer any questions and on the presentation or on Vinny. And you'll see him doing a few. He is a little is there browsing here.
Yeah, can you tell us about the equipment that you have to handle him?
Sure. This equipment hasn't really changed. We use a lot of nylon in this now, but it hasn't really changed in over 4,000 years. You still have the jesses that hold his feet, and they hold it equally on either side so that he doesn't strain one leg or the other if he flies off. When he flies like that, you'll see him. That's called baiting, and that baiting means that he just wants to go somewhere else right now, and so you restrain him with those jesses. And a lot of that's the other thing to remember too, is a lot of the English language that we have, a lot of the words that we use or expressions that we use comes from falconry. And when you're controlling the bird, for example, you take the jesses, I don't know if you can see it there, and you put them under your thumb. I put them under my thumb and through my fingers. And that's where the expression "I've got you under my thumb" comes from. That's from just you're controlling the bird. You're controlling the bird by putting his jesses under your thumb. You see, he just did when he ruffled his feathers there. That's rousing. There's baiting. And when he baits, if he baits off the fist like that, ends up upside down and flaps around for a while, you'll see that his beak is going to be open and he's going to be panting. And that's bated breath. So if somebody says, "I'm waiting with bated breath," that comes from there. The expression under your thumb is quite obvious. The other one is what you do with the leash with a falcon when you're carrying it, is to wrap it around your little finger. And that's where the expression "wrapped around your little finger" comes from. So you can see he's got an adult plumage. He's got the dark head and the bars. He's a little bit cranky, a little bit harder to train than the younger one. This plumage is called the haggard plumage, or old hag. The expression "hag" comes from haggard, which is an adult falcon. They tend to be a little bit crankier than most. So, all sorts of the words in our English language and expressions come from falconry. And you can see the very dense plumage that he has. It's not a soft plumage like you'd have in an owl. It's very compact and streamlined, and that's what gives him that ability for great speed. So any other questions? Go ahead, Casey.
Yeah, is he a fully flighted bird?
No, that one elbow that you can see on his left wing there, it gives him, it will allow him to fly across a small yard or something like that, but he would never be able to fly any distance, or certainly wouldn't be able to catch any food of his own. So, but he's a very handsome little guy, and he's also very tame, and we can trust him. That even sometimes during the year, he can actually, people can pet him, which a lot of people like to do, and he seems to tolerate it all right. But right now he's just going in to grow his new feathers, and he is a little bit a little bit cranky, or he doesn't want to be here. He wants to be out having a bath probably right now.
Well, we won't keep him much longer. So everyone, let's wave goodbye to Vinny. And thank you so much for joining us today, Dr. Gord Court. It's always a pleasure to have you here. Thank you so much for talking about and showing us this beautiful bird species, peregrine falcons. Well, that is all the time that we have for this live stream, but join us next week as we launch a brand new mission for pollinators. This next month, we will talk about all of your favorite pollinators, so stop on by as we feature the Springfield Botanical Garden at 1 p.m. Central Standard Time. And so for the last time for the month of May, we will see you next week. Thank you so much.